Hello, this is Mrs. Ward, and I had a special request to go over the problems from 9.6, 9.7, the review worksheet on polar equations and polar coordinates. Feel free to fast forward this to where you need to be and what problems you need to see. No need to watch all of it. So here I go. I'm just going to begin. First one, every time you get graph paper, it's going to be slightly different, so you're going to have to like sort of orient yourself to the graph paper. So in these first couple, since the angles are in degrees, the polar coordinate paper gives me degrees. If I were looking at this from here to here is 30 degrees, that means this line halfway between would be 15 degrees. I don't have an inner circle, so that means, and it's clearly labeled 1, 2, 3, 4, those would be my radiuses. So 315 degrees would be here, radius of 4, plot the point. The next one, 135 degrees, here's 135 degrees, radius of 1, plot the point. The next couple are in radians, so my graph paper is switched to radians. From here to here is pi over 6, well half of pi over 6 would be pi over 12. So each one of these lines is going to be pi over 12. They want 13 pi over 12, so I could count all the way around, or I could know that pi is 12 pi over 12. So the next one will be 13 pi over 12, and I want a radius of 4, which will be that point right there. 3 pi over 2 is on the axis, radius of 1. So I plot that point right there. Okay, now the next ones I have degrees, and I have polar, and I want to switch it to rectangular. So remember, x is equal to r times the cosine of theta. So to find x, I'm going to say r times the cosine of 300 degrees. The cosine of 300 degrees is 1/2. So this will be 1, that should have been a 1 there. 1 times 1/2, and I get 1/2 for my x-coordinate. Y is equal to r times the sine of theta degrees, so y is equal to 1 times the sine of 300 degrees. The sine of 300 degrees is a negative square root of 3 over 2. So that's going to be a negative square root of 3 over 2. If I wanted to graph this on the paper that I have, I'm probably going to need a decimal approximation for that. And so that's going to be approximately negative 0.87. So I'm going to do 1/2 negative 8.7, plot that point right there. And doing a double check, 300 degrees I know is in my fourth quadrant. This point is in my fourth quadrant, so they do match. Okay, the next one, I'm going to have x is equal to 4 times the cosine of pi over 3. The cosine of pi over 3 is 1/2, so my x-coordinate will be 2. Y is equal to 4 times the sine of pi over 3. The sine of pi over 3 is the square root of 3 over 2. So this will end up being 2 times the square root of 3. A decimal approximation for that is going to be approximately 3.5-ish. So I'm plotting 2, 3.5-ish. So right about there. Pi over 3 is in the first quadrant. This point is in the first quadrant, so they do match. Next one, I have 7. I have 4, and then 3 pi over 2. So x is equal to 4 times the cosine of 3 pi over 2. The cosine of 3 pi over 2 is 0, so my x-coordinate is going to be 0. Y is equal to 4 times the sine of 3 pi over 2. The sine of 3 pi over 2 is negative 1, so my y-coordinate is going to be negative 4. Applying the point 0, negative 4, it's going to be right there. Last one, and like this, x is equal to 1 times the cosine of pi. The cosine of pi is negative 1, so I'm going to have an x-coordinate of negative 1. Y is equal to 1 times the sine of pi. The sine of pi is 0, so I'm going to have 0. So I'm plotting negative 1, 0. And I guess I should be writing like 0, negative 4, and negative 1, 0. I should be writing the ordered pairs. Okay, now I want to convert each pair of rectangular coordinates to polar coordinates. Here, when you're going from rectangular to polar, you have to be kind of careful, because when I go to find my angle, my calculator is only going to give me an angle from 2 quadrants, and I'm going to have to adjust. So let's go through it. So if I were to plot 3, positive 3 over 2, and then a negative 3 times the square root of 3 over 2, my x is positive, my y is negative. I see that my point's going to be in the 4th quadrant. And that's good because I don't have to adjust, and I'll explain why in a second. Your 2 formulas that you need to know, because remember, polar coordinates come in the form of r and then theta. I'm going to say r squared is equal to x squared plus y squared. So r squared is equal to 3 over 2 squared plus a negative 3 times the square root of 3 over 2 squared. So when I do all this, I get r squared. If you do all this in your calculator, you are going to get 9, I believe. Yeah, because I'm going to get 36 over 4. So r squared is equal to 9, which means that my radius is equal to 3. So that's the first part. My radius is equal to 3. To find my angle, the formula is the tangent of theta is equal to y over x. So I'm going to say the tangent of theta is equal to negative 3 times the square root of 3 over 2, and that's all over 3 over 2. I'm assuming most of you are not going to try and remember your unit circle at this point. You're probably just going to plug it into your calculator, which is fine. When you do that, you're going to get theta is equal to, and as a radian, it's going to be negative 1.05-ish. It's 472. Let's do 472. And those of us who know our unit circle, we know that's negative pi over 3. Whatever. So when I do this, I'm going to get negative, I'm going to write negative pi over 3. You can write the negative pi over 3. Well, think about graphing this. If I were graphing it, I would go negative pi over 3. Should be here. So that is going to be in the 4th quadrant, which matches what I thought the point should be. So I'm good with that one. Now, the next one, when I look at this point, my x is negative, my y is positive, which tells me I'm going to be in the 2nd quadrant somewhere. So when I go to do this, I'm going to start it off the same way. I'm going to say r squared is equal to negative 2 squared. Oh, negative 2. Whoopsie. Wrote that wrong. Let's try that again. So this will be negative 2 times the square root of 3 squared plus 2 squared. So that'll be 12 plus 4, so that's 16. So r squared is equal to 16, which means r is equal to 4. So I know my 4. Now when I go to do the angle, I'm going to say the tangent of theta is equal to my y, which is a positive 2, over my x, which is a negative 2 times the square root of 3. So in my calculator, I'm doing the inverse tangent of that whole thing to get my angle. So give me a second. If I know my unit circle, I know that it's negative pi over 6. So theta is going to equal a negative pi over 6. If you just put in your calculator without thinking about the unit circle, you're getting as a radian a negative 0.524. So when I go to do that, when I go to write that, negative pi over 6 would be down here in this quadrant. And my radius, I said, was 4, so I would be plotting the point here. But I want to point up here in the 2nd quadrant. So what happens is I need this to go all the way over here to this side. So to do that, there's 2 ways to do it. The most common way is, since I want this angle to be exactly halfway across the unit circle, the best way to do it is to leave your radius positive and then just add 1 radian, or 3.14. So if I do this, I'm going to get 5 pi over 6. If you're in decimals, which is completely fine, you're going to get 2.62. So this will be 4 and then 5 pi over 6. So what's going to happen is, if your point is in the 2nd or in the 3rd quadrant, you're going to have to adjust. And we did this in trig. it's going to have to adjust because your inverse tangent is only going to be defined in the first and the fourth quadrant. So if your angle's in the second or third, you're just going to have to add pi, or if you switch it to degrees for some reason, you're going to have to add 300 or 180 degrees. Okay, the next one. I have negative square root of 2, negative square root of 2. Checking. Both are negative. It's going to be in the third quadrant. That instantly tells me at the end of this problem, I'm going to have to add 180 degrees or pi or 3.14 to my radians. So r squared is equal to negative square root of 2 squared plus negative square root of 2 squared. So r squared, can I skip to 4? So r is equal to 2. And then to do the inverse tangent is going to equal negative square root of 2 over negative square root of 2. So I'm doing that in my calculator, doing this in my calculator. When I do that, I get a negative pi over 4. Don't know that as a, which would be negative 0.78. So theta, oh, I'm sorry, it's going to be positive 7.8, or positive pi over 4. So since that's putting me, since this radius of 2 and then a positive pi over 4 would put me in the first quadrant, and I want to be here in the third quadrant, I'm going to add 1 pi to that. So I'm going to say 5 pi over 4. If you're a decimal person, you're adding pi to that 0.78, and you're saying 2 and then 3.93. Either one is acceptable. Okay, moving on to the next one. I am saying r squared is equal to 1 squared plus a negative square root of 3 squared. So this will be 1 plus 3, so 4. So r is equal to 2. Then my inverse tangent, I'm going to skip to this inverse tangent right off the bat. And I'm doing my y, which is a negative square root of 3 over 1. And I believe that's going to be 6 negative pi over 3. But before I write that, I'm going to double check because I'm not doing this again. Why did I ever doubt myself? It was a negative pi over 3. If you're a decimal person, that's a negative 1.0472. So right now, my radius was, what was my radius? My radius was 2. And I said a negative pi over 3. This point is in the fourth quadrant. This point is also in the fourth quadrant, so I'm fine. I do not have to adjust. Okay, these ones were the graphing of the rose curves, and these are the only ones that we're going to expect you to graph by hand. Remember, you're looking, when I look at this equation, I know 2 things. First of all, I know my max is going to be whatever this number is, so my max is going to be 3. Then this 5 is odd. So since it's odd, that tells me that there are going to be 5 petals to make this graph. And then I can take 2 pi and divide it by 5, and that tells me that's how far apart each of the petals are. If you want to do degrees instead, because some people like working in degrees better, that means that that's going to be about 72 degrees apart. And I just took 360 and divided by 5, whatever makes you happier. So then what I'm going to do is, first of all, it's going to ask me to find my zeros. So I'm going to say 0 is equal to 3 sine 5 theta. Divide both sides by 3. And then it's asking me, when is a sine function? Think of this. When is a sine function equal to 0? Well, it's usually equal to 0 at 0 and pi. So I'm going to say 0 and pi are the 2 places that the sine is usually equal to 0, but it's 5 theta, so I'm going to set these both equal to 5 theta. So dividing both sides by 5, my zeros are going to be at 0 and pi over 5. And I could keep on continuing. I'm just going to leave it like that for right now. Now I know what I need to find my max. Well, my max is 3. That's going to happen when the sine is equal to 1. So I'm asking myself, when is the sine of a number equal to 1. And you say, well, that usually happens at pi over 2. So now that 5 theta is going to equal to pi over 2, because that's what's inside here, which means theta is equal to divide both sides by 5 or multiply by 1/5, and that's going to be pi over 10. So that's going to be where my max is. So here, when I'm trying to figure out pi over 10, if you're not good with the fractions, you're going to change that to degrees. So go ahead, let's just change that to degrees. Maybe that'll help you out. So if I do that, I'm going to get 18 degrees. Well, then I can sort of wrap my head around 18 degrees because I know that this here, pi over 6, is 30 degrees. So 18 degrees is going to be a little bit more than half. And I know my max is 3, so a little bit more than half. 1, 2, 3, and I'm going to put a dot right there. This is a sine function, which tells me that the left side matches the right side. So I can automatically reflect this point over and draw another point here. And I have 2 of my pedal points, if that makes sense. If I want to find more, I know that one is at pi over 10. I know the difference between them is 2 pi over 5. So what I'm going to do is I'm going to go down here. I'm going to take that pi over 10, that's where my first max occurs, and I'm going to add 2 pi over 5. And when I do that, and you can do it in your calculator, you can change this so that it's 4 pi over 10, and you get 5 pi over 10, which is a pi over 2. So I'm going to have a max of pi over 2. So 1, 2, 3. So pi over 2, 3. If I add 2 pi over 5 to this, because I'm going to just keep on adding 2 pi over 5, when I do that, 5, I'm going to get this one here. So that's 5, 6, 7. So that's 7 pi over 10, which is this one right here. So going over here because I ran out of room. So 7 pi over 10. Now I'm going to add 2 pi over 5 again. And if I were in degrees, I could be just adding degrees. And when I do that, it's going to be 11 pi over 10. You know, I'm afraid I'm losing you guys in the fractions, so I sat here and thought about it for a while, and this is 18 degrees. So I'm just going to, and I know the difference is 72, so if I add 18 plus 72, I get the 90, and that would give me this point right here. And then if I add 90 plus 72, that gives me, why can I not think? That gives me 162, and that's how I have this point here. If I keep on adding 72, the next one is going to be 234. Well, this one, so this is 215. No, this is 215. Yes. So it's going to be here somewhere. Radius of 3. Because this one's 240. And then add 72 again. And I get 306. So this is 300. It's going to be a little bit more than 306. And again, these two should mirror each other. And then if I add 72 again, I'm going to get 360, and that should be good. So here I'm going to sketch my rose curve. I think degrees might be a lot easier for you guys than radians. So let's just do degrees. So the next one, oh, that's really big. I have 5 cosine 5 theta. So it's basically going to be the same work as the last one, except for my min and my max and my zeros are going to be at different places because it's a cosine function instead of a sine function. Remember, the cosine matches from top to bottom. So first of all, I know my max is going to be 5, because that's the number, and that's because of this 5 here. Then to find, I'm going to ask myself, when is the cosine of a number equal to 1? Because that's when the max would occur. And that usually happens at 0. So the cosine of 5 theta is going to equal 1. And that happens usually at 0 and at 2 pi. I like to have 2. So this will be 5 theta is equal to 0. 5 theta is equal to 2 pi. Divide both sides by 5, and I get 0 and 2 pi over 5. And I could have sworn we just did that one before. And I'm going to change that to degrees, and that, I believe, is 72 degrees. So then when I have, that's when my max is going to occur. So my max is going to occur at 0. My max is 5, 1, 2, 3, 4, 5. And that doesn't really help me. I can't mirror that because it's right on the axis, so that doesn't really help me. Then 1 is going to be at 72 degrees, which, this is 30, this is 60, 72 would be about here. So, and then, so 1, 2, 3, 4, 5. And then I can mirror that down here. So 2, 3, 4, 5. So, and I know there's 5 petals. I don't know if I said that before, but there are 5 petals. I forgot to find my zeros, so let's find the zeros. 0 is how I find my zeros. Divide both sides by 5, and I get 0 is equal to cosine of 5 theta. When is the cosine equal to 0? Well, that happens at pi over 2. And it also happens at 3 pi over 2. And these are 5 thetas, so this will be pi over 10 and 3 pi over 10. Those are my zeros. Okay. So 72 degrees. Again, remembering from last time, if I take 360 divided by 5, because there's 5 petals are equal distance apart, I'm going to have 72 degrees in between each one of these petals. So that means if I take 72 and add 72, I get 144. So this is 135. This is 150, so it's somewhere in between there. 1, 2, 3, 4, 5. And then I can mirror it down, or I can add 72 again, whichever. So that's 216 if I added 72, which is going to be right short of 215, or right past 215, so right about there. And there I have my 5 petals. 1, 2, 3, 4, and 5. Okay, moving on to the next one. This one, I have 2 theta, 3 sine 2 theta. Since that 2 is even, that means I'm going to have twice as many petals. So this one, I am going to have 4 petals. My max is going to be that 3. My 0, so I'm going to say 0 is equal to 3 sine 2 theta. So 0 is equal to 2 theta, sine of 2 theta when I divide both sides by 3. The sine is equal to 0 at 0 and pi. Set those both equal to 2 theta. So my zeros are going to occur at 0. So my zeros are going to occur at 0 and pi over 2. That's what I get when I divide both of these by 2. Now to find my max, when is the sine equal to 1? And you say pi over 2. So 2 theta has to equal pi over 2, which means 1 theta is going to equal divided by 2, or multiplied by 1/2, pi over 4. So if there's 4 petals, I'm going to take 360 degrees and divide it by 4 and get 90 degrees. This one might be actually easier to do in radians, or take 2 pi and divide it by 4 and get pi over 2. So my first max happens at pi over 4 or 45 degrees. So, and my max is 3. So 1, 2, 3. Left and right match, so I could just hop it over here, or if I add 45 plus 90, I'm going to get 135. Add 45 again, you're going to get 215. Add 45 again, and you're going to get 3. And there are going to be my 4 petals. Okay, the next one is I have sine 5 theta. So it's basically the same one we just, you know what, this one is exactly like, going back, it's the same one as 13. So it's this exact same picture as 13, except for your max is going to be 2 instead of 3. So I'm just going to say same as 13. Same as number 13, except for your max is 2 instead of 3. No need to do that one again. All right, so this one you want to convert each rectangular equation to polar. Going from rectangular to polar is extremely simple. Every time you see an x, you're going to replace it with r cosine. Every time you see a y, you're going to replace it with r sine. And then simplify. So before I do this, I'm going to get rid of this 4 in the denominator. So I'm going to multiply both sides by 4. So I'm going to have 4y is equal to x squared. Replacing this y, I'm going to have 4r sine theta. And then since this is squared, I'm going to have r cosine theta. But that's going to be squared. So when I square that, I'm going to have r squared and cosine squared. They're both squared. So when I do a polar equation, I want r on one side. I see that I have r on both sides. So what I'm going to do is I'm going to divide both sides. I'm going to divide both sides by r. And when I do that, I'll have 4 sine theta is equal to cosine squared theta. And then there's 1r in front of that. Solving for r, I'm going to divide both sides by cosine squared. Then this is where those simplifying trig identities really come into play. Remember those? Yeah, they were fun. All right, so here I'm going to have 4, and I'm going to write sine over cosine times 1 over cosine. Because cosine squared would be cosine times cosine, and then that 4 sine would be that. Sine over cosine is tangent, so this will be 4 times the tangent of theta, and then 1 over cosine is secant theta, and that's equal to r. And that's all you have to do. Replace the x and the r. So this one, same thing. I don't like having that 3 in the denominator, so I'm going to multiply everything by 3. And when I do that, I'm going to have 3x is equal to y squared. That is a y. So replacing the x with r cosine, replacing the y with r sine, so I'm going to write this as r squared sine squared theta, because they're both squared. I'm going to divide both sides by r. So when I do that, I have 3 cosine theta is equal to r sine squared theta. I want r on one side by itself, so I'm going to divide both sides by sine squared. And when I do that, I'm just going to have the 3 out in front. I'll just keep it with the cosine, doesn't really matter. And I'll put that over 1 sine. And then I'm going to leave the other sign as 1 over sine. And this is equal to r. Cosine over sine is cotangent. And 1 over sine is cosecant. And that's my polar equation. Now, so before I start this, I'm gonna actually FOIL these out. So I'm gonna have x squared minus 2x plus 1, y squared minus 6y plus 9 is equal to 10. I'm going to write x squared plus y squared minus 2x minus 6y, and then this 1 plus the 9 I'm subtracting and putting them over the other side. Well, this is 10, so I subtract 10 from both sides and it's equal to 0. I remember that I have an identity that says that r x squared plus y squared is equal to r squared, so I'm going to write r squared there. Then minus 2r cosine theta minus 6r sine theta. Remember, replacing the x with r cosine, the y with r sine is equal to 0. I am going to leave r squared on one side, put everything else on the other side. Then at that point, I am going to divide everything by r. And I'm going to get r is equal to 2 cosine theta plus 6 sine theta. And that's it. I have r on one side by itself set equal to my two things. Everything is in polar form because I just have theta and r, no x's or y's. Okay, the next one's the exact same procedure. I'm going to first FOIL. So x squared minus 6x plus 9 plus y squared plus 2y plus, oh, that's minus 2y. My bad. It's minus. I'll fix that in a second. Is equal to 10. That's minus. I'm putting my x squared and my y squared together. Minus 6x minus 2y. This 9 plus this 1 is 10. Subtract 10 from both sides is equal to 0. So it's basically the same problem we just did. This is an identity that equals r squared. Then every time I see x, I'm going to write r cosine theta. Anytime I see y, I'm going to write r sine theta. And this is equal to 0. So I'm going to say r squared is equal to adding everything over to the other side. 6 cosine theta plus 2 sine theta. Oh, forgot my r. Forgot my r. Okay. Divide everything by r. 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 So I'm going to say r is equal to 6 cosine theta plus 2 sine theta. Okay, now the next one is you're converting from polar to rectangular. Here you don't have a direct way of doing every single problem. You kind of have to think about it. So I'm going to use the things I'm going to use is that r squared is equal to x squared plus y squared. Then I'm also going to use the x is equal to r cosine theta and y is equal to r sine theta. And then I'm also going to remember that the tangent of theta is equal to x over y. Those are the four things that I can use when I do this. So when I have this one, the goal is to get rid of the r's and the thetas and replace them with x's and y's. So the first thing I see is I see this tangent of theta. Tangent of theta I know is equal to x over y. So I'm going to start by writing that. So I'm going to say r is equal to x over y. And then secant, can I make 1 over cosine theta? Because that's what secant is. To simplify this, let's say I wanted to put that cosine over to the other side. So I'm going to multiply this side by cosine of theta, which means I'm going to multiply this side by cosine of theta. When I do that, I have r cosine theta is equal to x over y. Well, r cosine theta is x. Oh my, oh my. Oh, I really don't want to start over again. And I'm not. So I just made a huge, huge, huge mistake. Huge. And so back up, pretend like I didn't do that. If I could edit, I would gladly edit, but I can't edit. So we're just going to tell you that Mrs. Ward, tangent is y over x. Oh, my bad. My bad. My so bad. So this is y over x, which makes this y over x. Okay. Oh my, such a bad mistake. I'm still a good person though. Y over x. Now when I go to simplify this, I'm going to multiply both sides by x. So multiply this side by x, multiply this side by x, and I get x squared is equal to y. Okay, let's try doing this one without making a mistake. So this is r is equal to 3. It's cotangent. So do we all agree that this could be 3 cotangent? Is it, well, go over here. Cotangent is equal to 1 over the tangent, or the reciprocal of tangent, which means if tangent is equal to y over x, then cotangent would be x over y. So I'm going to write 3x over y for this whole thing. Cotangent is x over y. Cosecant is 1 over sine. The only trig functions that I can go directly into x and y without having that r is cotangent and tangent. Now I'm going to multiply both sides by sine of theta. So sine of theta. So I'm going to have r sine theta is equal to 3x over y. So this will be y is equal to 3x over y. So y squared is equal to 3x. And I'm just going to leave it like that. Again, I replaced the thetas and the r's with x's and y's. So this one, again, everyone's going to be different. I don't have a tangent. I don't have a tangent or a cotangent. So I'm going to have to find a way of doing like r sine, r cosine. I do know, so here I have the r, and then here I have sine and cosine. If I multiply everything by r, so if I multiply this side by r, and I multiply this side by r, so everything's going to get multiplied by r. I'm going to have r squared is equal to negative 4r cosine theta plus 4r sine theta. When I multiply both sides by r, this r squared I can make x squared plus y squared, because that's what r squared is equal to. This 4r cosine will be x. This 4r the sine will be 4y. And then I'd be happy. So then I'm going to add, so I'm going to have x squared plus 4x plus y squared minus 4y is equal to 0. If you get that far, I am so very happy. They actually want you to go on and simplify this. So if you see the answers at the bottom, what they did is they completed the square here, and they made this x plus 2, because half of 4 is 2 squared. Well, when I square 2, I'm adding 4 here, which means I have to add 4 over here. And here's this minus, or this plus. And then half of negative 4 is negative 2. Negative 2 squared is 4. Add 4. And I get 8. And then let's go back to the archives when we just did this, like not even 2 weeks ago. If you divide everything by 8, you're going to have x plus 2 squared over 8 plus y minus 2 squared over 8 is equal to 1. You should recognize it as a circle. Maybe not. Again, if you get this far, like this far here, I am so very happy. Very happy. So doing the next one, again, I have cosine and sine on one side. I have just a single r on the other side. I'm going to multiply everything by r. So I'm going to have r squared is equal to negative 2r cosine theta minus 4r sine theta. So I'm going to have x squared plus y squared is equal to negative 2, that is x, minus 4, r sine is y. Putting them on one side, setting it equal to 0. plus y squared plus 4y is equal to 0, and there you're done. That's all you've got to do. I believe that's it. That is it. So I hope this helps. And if you have any questions, come email us or meet us in the collaborative room. Have a great day.